In this lecture, we're going to begin our discussion of the concept of perfect competition. A perfect competition is one of the most important market structures to understand in economics, not because it describes the real world very well, but because it is the market structure to which we compare everything else. So in this first lecture, we're going to start by talking about exactly what we mean by a market. We've used the term a lot in Econ 101 without really defining it. We're going to describe briefly the four basic market structures that we will look at in this course. We'll discuss the assumptions of the perfect competition model. We'll look at the demand curve for a perfectly competitive firm, and then we'll talk about basic profit maximization in perfect competition. Right, so when we think about a market, such as the market for candy, we really need to have a better idea of what we mean by that. What belongs in the market, what doesn't belong in the market. In general, when we talk about markets, we think about goods that we consider to be very close substitutes for each other. So things that are in the market for candy might include chocolate bars. Maybe they can contain hard candies. Maybe that market contains gum. We will agree that things belong in that same market for candy if we think that the general consumer considers them to be close substitutes for each other. When goods are close substitutes for each other, that's going to indicate that an increase in the price of one good will cause at least some people to switch their purchases to the other good. If that's not true, then the goods probably aren't close substitutes for each other. It turns out we have a better way to measure how close substitutes or goods might be for each other. That measurement is called the cross price elasticity of demand. And with this measure, we can actually attempt to identify the relevant market for any good. Right, so we define the cross price elasticity of demand as follows. We're calculating the percentage change in the quantity demanded of good X in response to the percentage change in the price of good Y. Right? So what we're asking is, if we change the price of good Y, how does that affect demand for a different good, good X? Okay, as an example, imagine that for some people margarine and butter are substitutes. Right? So we could calculate the cross price elasticity of demand for the two by looking at how the percentage change in the price of butter affects the percentage change in quantity demanded of margarine. Right? As it turns out, there are two pieces of information with the cross price elasticity of demand that are useful for us. One piece of information is whether or we get a positive number or a negative number for our cross price elasticity. If you have a positive number, it does mean the goods are substitutes. That means that an increase in the price of good Y causes an increase in demanded of the substitute good X. If instead we get a negative number, it means the goods are complements, because an increase in the price of good Y would then cause a decrease in quantity demanded of good X. Right? So as price of good Y goes up, you use less of both good Y and less of good X. They're complements. So if we want to consider goods in the same market, we can use this kind of benchmark rule of thumb. If the cross price elasticity of demand is greater than about 2 or maybe 3, depending on which professional you consult, we'll consider the goods to be very close substitutes and consider them to be likely in the same market. All right, so that's how we define markets. Now we need to talk about market structure just briefly. Market structure, all right, so this is what we'll be talking about in the next couple of units. Market structure has to do with how many producers are in a market, right? In other words, how many firms, and how do they behave in the market. In economics, we define four basic market structures. We call them monopoly, perfect competition, oligopoly, and monopolistic competition. So just really, really briefly, let's look at how we define them by the number of producers and their behavior. Right, so monopoly is pretty easy. We've got one producer in monopoly. And what we're going to see is that under monopoly, the result is that a monopolist is going to produce less than the efficient quantity, and they're going to end up charging higher than optimal prices. Right? A complete opposite of monopoly is perfect competition, where we have many, many, many producers. Right? And the primary behavioral characteristic of perfect competition is that firms are price takers, and we'll see what that means in just a minute. Right? So our two remaining market structures are probably more characteristic of the real world than either monopoly or perfect competition. In oligopoly, we have a few producers, right? More than one, but a whole lot less than many, many. And what will be interesting about oligopoly is that we will observe strategic interactions among firms, and that actually makes it very fun to analyze. The final market structure we'll discuss is known as monopolistic competition. In this market structure, there are many firms, not as many as perfect competition, but a lot more than oligopoly. And the primary behavioral characteristic we notice is product differentiation, right? That firms compete by producing goods that are close but not perfect substitutes for each other. Right, so next we're going to talk a little bit more specifically about perfect competition itself. Right, so economists typically make certain assumptions of perfect competition, and in fact, if any one of these assumptions is violated, we'll say that the market is not perfectly competitive. Right, so assumption number one, we've already discussed, many firms. Assumption number two is equally important. We assume that these firms are producing identical products. Textbook will also call them homogeneous products. Either term's fine. These two assumptions combined will mean that the firms have to be price takers. And again, we'll see what that means in just a minute. Right? But if you have many firms producing identical products, you aren't going to have any power to choose your own price. Right? A second assumption is that there is free entry and exit of firms. Free here does not mean costless. Free means it is possible for new firms to enter this industry, and it is possible for firms that are losing money to exit this industry. And again, we'll see what that means later in the course, particularly when we talk about monopoly, where there is not free entry and exit. Right? Another assumption, firms have perfect information about the costs that they face and demand conditions. If they don't have this information, they won't make perfectly competitive choices. Finally, we assume there are no distortions in the market. There are no government price controls. We are ignoring taxes. We're also ignoring problems like pollution, and that's going to be a big problem for our perfect competitive model. If we have pollution or other externalities, we won't have perfect competition. So again, all of these assumptions, every single one of them has to be true to consider a market perfectly competitive. So at this point, you can probably see why the real world is not likely to have many perfectly competitive industries. Right. So next we need to think about what we mean when we say a firm is a price taker in perfect competition. So imagine we're thinking about the market for oranges. So on the left-hand side of the diagram here, we've got the market demand curve and market supply curve for oranges, and we've identified the equilibrium price of oranges as being 75 cents. Right. So let's think about what that means for an individual orange grower. Right. Well, does this seem like a reasonable model for perfect competition? Yep, one farmer's oranges in Florida are probably a lot like another farmer's oranges in Florida. We probably have fairly identical products. So if you're an individual orange grower in Florida, can you charge a price greater than 75 cents a pound for your oranges? Well, the answer is probably not. If your oranges are identical to everybody else's, why would anyone be willing to pay you more than 75 cents a pound for your oranges? Right? So as the individual orange grower, you're not going to be able to charge a price higher than the market price because people will simply buy from somebody who's selling at a lower price. All right, so would you be ahead if you decided to charge a price lower than 75 cents? All right, so let's say you undercut the competition and offer your oranges for 70 cents. Sound like a good idea? Well, it is true that you would be able to sell your oranges for 70 cents, right? But if you take a look at that market supply curve for oranges, what it tells us is that every individual firm that wants to sell its oranges at 75 cents is able to sell them, right? That's what equilibrium means, that the quantity that suppliers want to provide is the equilibrium quantity at 75 cents. So you can sell all of the oranges that you have produced at 75 cents. Or you could drop the price and sell all of the oranges you produced at 70 cents. Which one's a better deal for you? I think you'd rather take the 75 cents. Right, so combine these insights. You can't sell them for more than 75 cents. It's not good for you to sell them for less than 75 cents. So guess what? You're going to take the market prices given. You are going to sell your oranges for 75 cents a pound. So what we can do to show this for the individual orange grower is we can simply kind of extend that price line across our diagram. So you can see I've just sketched a dotted line from the market diagram to the individual diagram. I've made it solid here, and I'm labeling it as three different things. Right? This is the demand curve that faces you. It shows you that demand for your oranges is perfectly elastic. Right? That happens to be the price. The market price of 75 cents is the same as the demand curve for you. And this price is also equal to your marginal revenue, right? Marginal revenue. What is the revenue that you would earn from selling one more pound of oranges? Well, it's 75 cents. 75 cents is your marginal revenue, and it's the same as price. All right, so imagine then that demand increases. If the market demand for oranges increases, we're going to need to show that increase in demand on the left side of our diagram. How will that affect you? Well, let's shift out our demand curve to the right, right? And imagine that the new market price for oranges is 80 cents, right? Well, what do you want to sell your oranges for? Not 75 cents, because now market equilibrium price of oranges is 80 cents. You're not going to sell them for more than that either. You're going to take the new market price as given, right? And so we can sketch the new demand curve for you, and it's just shifted up vertically to the new price of 80 cents. All right, so the last thing we'll talk about in this portion of the lecture is the notion of profit maximization, right? So we've already introduced the idea of profit maximization. You want to produce up until the point where marginal benefits just equal your marginal cost. Well, the marginal benefit of production is your marginal revenue. What extra revenue do you get if I sell another unit? Marginal cost, of course, is how much does it cost you to sell an additional unit, right? So here I've got the marginal revenue curve, the price curve for our individual orange grower. So what I need to add to this is a marginal cost curve. Right, so I'm going to do that. I'm going to sketch a J-shaped curve. That's our marginal cost curve. So I'm sketching a typical J-shaped marginal cost curve into the diagram. And then what I'm doing is I'm applying this rule of thumb, right? If profit maximization occurs where marginal revenue equals marginal cost, then I simply need to identify where that is. And so I'm just going to grab up my pen here. Okay, notice that where marginal revenue equals marginal cost, it happens to occur right here at the intersection of that marginal cost curve and the marginal revenue curve. And so what I do in order to indicate that is I just draw a vertical line down to my axis, and I mark that as Q star. Right? This is the profit maximizing quantity of output for our firm. Right? So here's the same diagram, right? So I've marked Q star as the profit maximizing quantity. And now let's just take a look and see what would happen if there's an increase in demand for oranges, right? Well, we saw just a little bit ago, when there's an increase in demand, it causes market price to increase. So we'll have to show our market price curve shift, or the demand curve for our individual grower, its marginal revenue curve, its price curve, needs to shift up vertically. Right? So here's our new demand curve. Right, so you can see it's shifting up vertically. And so now what we need to do is, again, apply our rule of thumb. Marginal revenue equals marginal cost. So we need to indicate our new quantity, right, by first of all finding where marginal revenue equals marginal cost, and then sketching that line, that vertical line, down from that point, and indicating the new quantity, which I've indicated as Q2 here. Right? So in the next lecture, we're going to make this a little bit more complicated by adding the average total cost and average variable cost curves, and then looking for firm profit in addition to this profit maximizing level of quantity.